Grade 9 Structure of the Atom Part 1 NCERT Textbook Questions and Answers. Page number 47. What are canal rays? Answer. Canal rays are positively charged radiations consisting of particles which have a charge equal in magnitude but opposite in sign to that of electron. The mass of a canal ray particle is 2000 times as that of the electron. This particle is also known as proton. Page number 47, question number 2. If an atom contains one electron and one proton, will it carry any charge or not? Answer. No, it will not carry any charge because electron has negative charge and proton has positive charge. Both the particles neutralize each other. Page number 49, question number 1. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. Answer. According to Thomson's model, an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude. So, the atom as a whole is electrically neutral. Page number 49, question number 2. On the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? Answer. According to Rutherford's model of an atom, nucleus is positively charged. Therefore, protons are present inside the nucleus. Page number 49, question number 3. Draw a sketch of Bohr's model of an atom with 3 shells. See the picture. Page number 49, question number 4. What do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than gold? Answer. If the alpha particle scattering experiment is carried out using a foil of a metal rather than gold, there would be no change in the observation. In the alpha particle scattering experiment, a gold foil was taken because gold is malleable and a thin foil of gold can be easily made. It is difficult to make such foils from other metals. Page number 49, Question number 1. Name the 3 subatomic particles of an atom. Answer. The 3 subatomic particles present in an atom are protons, electrons and neutrons. Page number 49. Question number 2. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? Answer. Atomic mass equals number of protons plus number of neutrons. Atomic mass of helium is 4U. Number of protons 2. Number of neutrons equals 4 minus 2, 2. Page number 50. Question number 1. Write the distribution of electrons in carbon and sodium atoms. Answer. The total number of electrons in a carbon atom is 6. The distribution of electrons in carbon atom is given by first orbit or K shell 2 electrons, second orbit or L shell 4 electrons. So, the distribution of electrons in a carbon atom is 2, 4. The total number of electrons in a sodium atom is 11. The distribution of electrons in sodium atom is given by first orbit or K shell 2 electrons, second orbit or L shell 8 electrons, third orbit or M shell 1 electron. So, the distribution of electrons in a sodium atom is 2, 8, 1. Page number 50. Question number 2. If K and L shells of an atom are full, then what would be the total number of electrons in the atom? Answer. The maximum number of electrons that can occupy K and L shells of an atom are 2 and 8 respectively. Therefore, if K and L shells of an atom are full, then the total number of electrons in the atom would be 2 plus 8, 10 electrons. Page number 52. Question number 1. How will you find the valency of chlorine, sulphur and magnesium? Answer. Valency of an atom is the number of electrons gained, lost or shared so as to complete the octet of electrons in the valence shell. The distribution of electrons in chlorine is 2, 8, 7. Chlorine needs 1 electron to complete its outermost shell. So its valency is 8 minus 7, 1. It gains 1 electron. The distribution of electrons in sulphur is 2, 8, 6. So its valency is 8 minus 6, 2. It gains 2 electrons. The distribution of electrons in magnesium is 2, 8, 2. So its valency is 2. It donates 2 electrons. Page number 52, question number 1. If number of electrons in an atom is 8 and number of protons is also 8, then 1. What is the atomic number of the atom? And 2. What is the charge of the atom? Answer. The atomic number is equal to the number of protons. Therefore, the atomic number of the atom is 8. 2. Since the number of both electrons and protons is equal, therefore the charge on the atom is 0. Page number 52, question number 2. With the help of table 4.1, find out the mass number of oxygen and sulphur atom. Answer. Mass number of oxygen equals number of protons plus number of neutrons. 8 plus 8 equals 16. Mass number of sulphur equals number of protons plus number of neutrons equals 16 plus 16, 32. Page number 53, question number 1. For the symbol H, D and T, tabulate 3 subatomic particles found each of them. Symbol H, protium, 1 proton, 0 neutron and 1 electron. Symbol D, deuterium, 1 proton, 1 neutron and 1 electron. Symbol T, tritium, 1 proton, 2 neutron and 1 electron. Page number 53, question number 2. Write the electronic configuration of any pair of isotopes and isobars. Answer. 2 isotopes of carbon are carbon 12 and carbon 14. The electronic configuration of carbon 12 is K shell 2, L shell 4. 2, 4. The electronic configuration of carbon 14 is K shell 2, L shell 4. 2, 4. Isotopes have same electronic configuration. Calcium and argon are a pair of isobars. Their electronic configuration, the electronic configuration of calcium is K shell 2, L shell 8, M shell 8, N shell 2, 2, 8, 8, 2. The electronic configuration of argon is K shell 2, L shell 8, M shell 8, 2, 8, 8. Page number 54. Compare the properties of electron, proton and neutron. 1. Electrons are negatively charged. Protons are positively charged. Neutrons are neutral. 2. Electrons are present outside the nucleus. Protons are present in the nucleus of an atom. Neutrons are present in the nucleus of an atom. 3. The mass of an electron is negligible. The mass of proton is 1 AMU. The mass of neutron is also 1 AMU. 4. Electrons get attracted towards positive charge. Protons get attracted towards negative charge. Neutrons are not get attracted. Page number 54, question number 2. What are the limitations of J.J. Thomson's model of the atom? Answer. Limitations of J.J. Thomson's model of the atom are: 1. It could be explained the experimental results of other scientists such as Rutherford, as there is no nucleus in the atomic model proposed by Thomson. 2. It could not explain the stability of an atom. That means how positive and negative charges could remain so close together. Page number 54, question number 3. What are the limitations of Rutherford's model of the atom? Answer. Limitations of Rutherford's model of the atom are: 1. It could not explain why a moving charge electrons does not lose energy and fall into the nucleus. 2. It could not explain the stability of an atom when charged electrons are moving under the attractive force of positively charged nucleus. 3. The model could not explain us to how the electrons are distributed in the extranuclear portion of an atom. Page number 54, question number 4. Describe Bohr's model of the atom. Answer. The main postulates of Bohr's model of an atom are as follows. A. Electrons revolve around the nucleus in special orbits called discrete orbits. B. While revolving in discrete orbits, the electrons do not radiate energy. C. These orbits are represented by the letters K, L, M, N, or the numbers N equals 1, 2, 3, 4. Page number 54, question number 5. Compare all the proposed models of an atom given in this chapter, structure of atom. According to Thomson's model, atoms consist of a positively charged sphere. According to Rutherford, a positively charged center in an atom is called a nucleus. All mass of an atom resides in the nucleus. As per Bohr's model, the positive charge in center of an atom called a nucleus. As per Thomson's model of an atom, electrons are embedded in the sphere of positive charge. As per Rutherford, electrons revolve around the nucleus. As per Bohr's model, electrons revolve in discrete orbits and do not radiate energy. According to Thomson's model, an atom is electrically neutral as positive charge equals negative charge. As per Rutherford's model, size of the nucleus is very small as compared to the size of the atom. As per Bohr's model, the orbits were termed as energy shells labeled as K, L, M, N or 1, 2, 3, 4. Page number 54. Question number 6. Summarize the rules for writing distribution of electrons in various shells for the first 18 elements. Answer. The rules for writing the distribution of electrons in various shells for the first 18 elements are given below. 1. The maximum number of electrons that a shell can accommodate is given by the formula 2n raised to 2, where n is the orbit number or energy level index. Maximum number of electrons in different shells are K shell n equals 1, 2 n raised to 2 equals 2 into 1 raised to 2 equals 2. L shell n 2, 2 into n raised to 2 equals 2 into 2 raised to 2 equals 8. M shell n 3, 2 n raised to 2 equals 2 into 3 raised to 2 equals 18. N shell n 4, 2 into n raised to 2 equals 2 into 4 raised to 2 equals 32, and so on. 3. The outermost orbit can be accommodated by maximum number of 8 electrons. 3. Shells are filled with electrons in a stepwise manner, that is, the outer shell is not occupied with electrons unless the inner shells are completely filled with the electrons. Page number 54. Question number 7. Define valency by taking examples of silicon and oxygen. Answer. Valency of an atom is the number of electrons gained, lost or shared so as to complete the octet of electrons in the valence shell. It is determined by the number of valence electrons present in the atom of that element. If the number of valence electrons of the atom of an element is less than or equal to 4, then the valence of that element is equal to the number of valence electrons. For example, the atom of silicon has 4 valence electrons. Its atomic mass of silicon is 14. Its electronic configuration is 2, 8, 4. So, the valency of silicon is 4. On the other hand, if the number of valence electrons of the atom of an element is greater than 4, then the valency of that element is obtained by subtracting the number of valence electrons from 8. For example, atom of oxygen has 6 valence electrons. Thus, the valency of oxygen is 8 minus 6, 2. Page number 55. Question number 8. Explain with examples. 1. Atomic number. 2. Mass number. 3. Isobars. 1. Atomic number. The number of protons present in the nucleus of the atom of an element is called its atomic number. atomic number equals the number of protons. Example, sodium atom has 11 protons, thus its atomic number is 11. 2. Mass number. The mass number of an element is the sum of the numbers of protons and neutrons present in the atom of that element. Example, the atom of boron has 5 protons and 6 neutrons. So, the mass number of boron is 5 plus 6, 11. Isobars. Atoms of different elements with different atomic numbers but same mass number are known as isobars. For example, argon and calcium are isobars. Page number 55, question number 8. Explain with examples. Isotopes. Give any 2 uses of isotopes. Answer. Atoms of an element having same atomic number but different mass numbers are called isotopes of that element. Example, hydrogen has 3 isotopes: H1, H2, H3. Uses of isotopes are: an isotope of uranium U-235 is used as a fuel for the production of electricity in nuclear reactors. 2. An isotope of cobalt is used in the treatment of cancer. Page number 55, question number 9. Sodium ion has completely filled with K and L shell. Explain. Sodium has atomic number 11, so its electronic configuration is KLm281. When the atom loses one electron, it acquires a positive charge. Sodium atom loses one electron to become stable to form sodium ion. Hence, it has completely filled K and L shell. Page number 55, question number 10. If bromine atom is available in the form of, say, 2 isotopes, bromine 79, 49.7% and bromine 81, 50.3%, calculate the average atomic mass of bromine atom. Answer. The average atomic mass of bromine is 79 into 49.7 by 100 plus 81 into 50 by 3 by 100 equals 3926.3 divided by 100 plus 4074.3 divided by 100 equals 39.263 plus 40.743 equals 80.006 U. Page number 55, question number 11. The average atomic mass of a sample of an element X is 16.2 U. What are the percentages of isotopes of X16 and X18 in the sample? Answer. Let the percentage of X16 equals X percentage, then the percentage of x18 equals 100 minus x percentage. Average atomic mass of x equals 16.2 U. Therefore, according to the given data, 16 into x by 100 plus 18 into 100 minus x divided by 100 equals 16.2. So 16x plus 1800 minus 18x equals 1620. Minus 2x equals minus 1800 plus 1620. X equals 180 by 2 equals 90 percentage. Thus, the percentage of x16 in the sample is 90 percentage. The percentage of x18 in the sample is 100 minus 90 equals 10 percentage. Page number 55, question number 12. If Z equals 3, what would be the valency of the element? Also name the element. Answer: atomic number of Z equals 3. Its valency, its electronic configuration is 2, 1. Valency of the element equals number of valence electrons equals 1. Name of the element is lithium, Li. Page number 55, question number 13. Composition of the nuclei of two atomic species X and Y are given as under: X 6 protons, 6 neutrons. For Y, 6 protons, 8 neutrons. Give the mass numbers of X and Y. What is the relation between the two species? Answer: mass number equals number of protons plus number of neutrons. So the mass number of X equals number of protons 6 plus number of neutrons 6 equals 12. Mass number of Y equals number of protons 6 plus number of neutrons 8 equals 14. As both X and Y are the same atomic number 6 but different mass numbers 12 and 14, hence they are isotopes. Page number 55, question number 14. For the following statement, write T4 true and F4 false. Statement 1 A. J.J. Thomson proposed that the nucleus of an atom contains only nucleons. Answer: the statement is false because in J.J. Thomson's model, nucleus was not present. B. Statement B. A neutron is formed by an electron and a proton combined together, therefore it is neutral. B. The statement is also false. Neutron cannot be made by combining an electron and a proton. It is neutral as it carries no charge. Statement C. The mass of an electron is about 1 by 200 times that of a proton. The statement is true. Statement D. An isotope of iodine is used for making tincture iodine, which is used as a medicine. The statement is true. Page number 55. Put tick against correct choice and cross against wrong choice in questions 15, 16 and 17. Question number 15. Rutherford's alpha particle scattering experiment was responsible for the discovery of A. Atomic nucleus, B. Electron, C. Proton, D. Neutron. Answer: atomic nucleus. Rutherford's alpha particle scattering experiment was responsible for the discovery of atomic nucleus. Question number 16. Isotopes of an element have the same physical properties, B. the different chemical properties, C. different number of neutrons, D. different atomic numbers. Answer is different number of neutrons. Isotopes of an element have different number of neutrons. Question number 17. Number of valence electrons in chlorine ion are A 16, B 8, C 17, D 18. Answer 8. Number of valence electrons in chlorine ion are 8. Page number 56. Question number 18. Which one of the following is a correct electronic configuration of sodium? A 2 8, B 8 2 1, C 2 1 8, D 2 8 1. The correct electronic configuration of sodium is 2 8 1. Page number 56. Question number 19. Complete the following table. Check the question and answer.